So it's worth reading these things up here. M is the midpoint of HG. So HG is here. So this is 6 meters between these two, because this is 12 meters down here. And N is the midpoint of DC. So again, this is 6 meters and 6 meters. I won't write that on again because I think you can tell from the diagram. So you want to work out BN. So you picture that triangle. You see this here. This is a right angle down here. This is a right angle triangle. So picture that triangle with B here, N up at the top, and C in this corner where the right angle is. So we're trying to work out that length. We've got BC, it's 4.5, and this CN here is the same as MG, it's 6 meters. So if we want to work out BN, we have to use Pythagoras. So we do the square root of 6 squared plus 4.5 squared, which is the square root of 36 plus 20.25. Add the 36, that's square root of 56.25. And sure enough, that gives us 7.5 meters. Work out the angle between line MB and the plane ABCD. The line MB then is this one here, and the plane here is ABCD. It's the base of the shape. So really we're talking about this angle here. So I'll do that on this page so you can see it more easily. So if I draw in that triangle, we've got B here, N and M. We know the length of BN is 7.5 from the previous question, and we know the height here because it's the same as the height here, so it is 3. So to work out this angle, which we can call theta, I'm going to do tan, because I know that tan has to do with opposite and adjacent, opposite divided by adjacent. So the opposite is 3, and then it's 7.5. So the angle is going to be tan to the minus 1 of 3 over 7.5. So that is 21.8 degrees. Work out the obtuse angle between the planes MNB and CDHG. So first of all, MNB. I'm going to switch to a different colour here so you can see it a bit better. MNB. So there's this plane here, and CDHG, which is the back of the shape. So we're talking about, imagine if this is a triangle that can move about with this as its fixed point. We're talking about this angle here, the amount that it's turned from being flat against that wall to being over here. So we could work out the smaller acute angle from there to there and then take it away from 180, because they'll add up to 180. So you picture this angle in here, that angle there. That's the angle that we're talking about. That's the acute angle, and the obtuse angle will be on the other side. So hopefully you can see this triangle that I'm talking about. So we've got N, C and B here, this here, and this is the angle that we're talking about. So we've got 4.5, this is 6. So to work out this angle here, we're going to do tan theta equals opposite divided by adjacent. So I'll go over to this page to do that. So we've got tan theta equals 4.5 over 6. So theta then is tan to the minus 1 of 4.5 over 6. Which is 36.9 degrees. So that's that angle there. We want this angle here. So those two angles are going to add up to 180. So we're going to do 180, take away that. So that's 143.1 degrees.